The exploratory data analysis, or EDA, is an important first step in the data analysis process. It summarizes the main characteristics of a data set, often using summary statistics, distributions, and visualizations. The primary goals of an EDA are to explore the structure of the data, identify patterns and trends, detect outliers and missing data, and to explore the data through various analyses and visualizations. In this lecture, we'll introduce you to the EDA using a subset of financial crimes data that you can download from data.gov. By the end of the lecture, you'll understand how you can take financial crime data and create a high-level analysis through an EDA.
This is the first lecture on data analysis. In this lecture, we'll cover the exploratory data analysis, or EDA, and walk through an example of an EDA using financial crime data that is freely available for download from the data.gov site. The exploratory data analysis, EDA, is an important step in the data analysis process that summarizes the main characteristics of a dataset, often using visual methods. The primary goal of an EDA is to explore the structure of the data, identify patterns and trends, detect outliers and missing data, and to explore the data through various analyses and visualizations. Using a combination of summary statistics, data exploration, and visualizations, you create an EDA that is specific to your project's needs and the type and nature of data you've collected. From a process perspective, the EDA typically follows your data transformation and data discovery process, which we covered in previous lectures. To help you get started, we've curated some sample credit card data, so you don't have to do too much transformation to get started here. Let's explore the sample credit card data, which you can use to do your own financial crimes data analysis. In our last newsletter, we introduced you to the financial crimes site that you can find from the data.gov landing page, where you can download financial crimes and fraud data from the US, as well as lots of other types of data. For this lecture, we curated a dataset representing multi-year credit card fraud, which shows instances of credit card fraud in the United States across a 10-year period. You can navigate into the Financial Crimes Enforcement Network page and then query data for download. There's a ton of interesting financial crime data here, but this is where we started our journey with the financial crimes data analysis. Let's now explore the credit card data in more detail and walk through different visualizations you can create using the data. After you download the dataset, open it in Microsoft Excel or an alternative spreadsheet application. You'll see 6 columns represented in the CSV data file, which are shown here. The dataset contains 4,104 rows across these 6 columns, which are described as follows. Year, month, represents the year and month of the recorded data. For example, 2014. State, the state where the transaction occurred. Industry, the industry in which the transaction took place. Suspicious activity, the type of suspicious activity detected, for example, credit or debit card. Product, the financial product involved, for example, debit card, credit card. Count, the number of occurrences for that particular combination of year, state, industry, suspicious activity, and product. Note that you can use different tools or programming languages to explore the structure of the data. For example, most of you know Excel, so this is a great place to start when exploring data. However, we'd recommend learning more about R and RStudio. R is an open-source programming language that supports statistical analyses, data science, and AI. With a few simple commands, you can load data into R and get a sense for the structure of data and whether there's any missing rows or data within your datasets. Now that you have a better understanding of the structure of the data, let's look at some sample visualizations. Within an EDA, you can employ different visualizations to show trends, relationships in the data, patterns, and so on. Depending on the type of data, you may find yourself creating different visualizations within your EDA. One of the first analyses you'll run is data distribution. This tells you if your data is normally distributed or if it skews to the right or left. Data distribution is important because you can understand the shape of your data, understand if there are outliers in your data, and better understand the standard deviation and range within your data. This particular chart was created in R and analyzed the frequency of credit card fraud across the year-month column, so a time-based view of the data. You should explore the distribution and shape of your data through all of the columns that are relevant to your data story or that interest you. The EDA gets more interesting when you begin to look at the data in different contexts. For example, you can represent the worst state for financial crimes in different ways, such as the total count of fraud within each state, the percentage of the total across the states, or taking the average count within each state. You can also use different visualizations to represent this analysis. For example, choropleth, bar chart, dot plot, and heat map. Here, we're using a choropleth map, which shades each state according to the total count of fraud. Darker shades indicate higher counts, while lighter shades indicate lower counts. We like the choropleth map because it's great for visualizing geographical distribution and identifying regional patterns. This choropleth map is an interactive map that shows the percentage total of financial crimes within each U.S. state. The higher the percentage, the darker the contrast color for that state. This choropleth map was created using Data Wrapper, a fantastic visualization tool that's used by many independent journalists and well-known news agencies. While analyzing the total count of financial crimes is useful, it may be misleading. Using per capita as a way to measure something is important for several reasons, particularly when comparing data across different populations or regions. For example, you can normalize the measurement for population size. The comparisons across categories are more fair, and you better understand the proportional impact. Take the following example. A city with 1,000 crimes in a population of 100,000 has a crime rate of 1%, while a smaller city of 500 crimes in a population of 10,000 has a crime rate of 5%. The smaller city has a higher per capita crime rate, indicating a potentially more serious problem despite having fewer total crimes. The visualization here is an interactive bar chart with two statistics, total count of crime and total per capita crime. What's interesting is that if you only use total crime, your story would focus on one set of states, whereas if you use per capita crime, your story would focus on a different set of states and provide you with a different angle. This is why it's important to explore different analyses of your data. They could lead to completely different stories. This was also created using Data Wrapper. If we take top 10 states by financial crime using the per capita total, then the top states that are problematic take on a slightly different ranking. And instead of using Data Wrapper for this visualization, we used R and a library called ggplot, which is a special graphics and plotting library available in the R programming language. When evaluating the financial crimes data for a story, the U.S. states is one pivot. You need to be looking at other dimensions to understand the full picture. So in this next visualization, we'll look at the specific financial crime and look at two statistics, total count and percentage of total. These are useful because they give you the raw total and then give you a proportion of how much that specific crime contributes to all financial crimes. For example, this table ranks the financial crime by total count and includes the percentage, both highlighted using conditional formatting to create a heat map. You're likely familiar with this feature because we covered it in one of our earlier lectures, but this is the conditional formatting feature available in Microsoft Excel. The final example we'll show is a single type of crime across the U.S. states. For this example, the visualization is a bar chart that shows the top 10 U.S. states by foreign transactions. Here, we've taken the top 10 states and ranked them from lowest to highest. We've used total count, total, of foreign transactions. But you could equally use per capita or proportion, percentage of, as we've shown earlier in this newsletter. Here again, we use R and ggplot to create the visualization.
In this lecture, you were introduced to the Exploratory Data Analysis, or EDA. We walked through the data and a few visualizations that you might implement when creating an EDA. In our next few lectures, we'll walk you through a more detailed exploration of the EDA and even get into more in-depth analyses for the financial crimes data. So, we'll see you in the next lecture.